Welcome back. Today we're going to talk about solving inequalities, and we're going to be looking at more specifically the absolute value ones, and looking at graphs and seeing how do the graphs relate to the actual solutions of inequalities, and how do we write those solutions. So let's go. This is no doubt something you've done in the past. There's a little trick to it, and it helps me to look at what the graph might look like. So for example, if I've got the absolute value of x minus 4 is less than 8, what could possibly be in here? So you could have like negative 8 is less than x minus 4 is less than 8. Well, let's think about this for a second. We want negative 8 to be less than x minus 4, and 8 is greater than x minus 4 because the absolute value, whatever's in there, the negative is going to be canceled out. And so for this one, when we have a less than, it's the case where it goes in a string like this. And so just to look at it graphically, it's going to be somewhere in this area here, right? Because negative 8 is less than, and anything in here would fit, and then less than 8. So this would be the graph of this. And so when I solve it, remember when I solve inequalities and they're compound like this, if I add something to the middle, it gets added to both sides because I'm solving two things at once. So negative 4 is less than x is less than 12. Okay, so this is the kind of thing where it sits in the middle here, and that kind of helps me to visualize what this inequality looks like. That's not actually my solution though. Okay, my solution is this. So that was helping me visualize what my inequality should be set up as. My solution is this, and we're going to write our solution in terms of our interval notation. So interval notation, it's not going away. And so negative 4 is less than x is less than 12 would be between negative 4 and 12. Using parentheses because I don't have an equal to, okay? So let's just envision this one for a second. If whatever's in here is greater than 5, okay, so it's going to be, bigger than or equal to 5. But the flip side of that is if it's a negative, okay, so think about this. So if it's a negative, so for example, if it's a negative 8, and I take the square root or the absolute value of that, that would be 8, so it would be bigger than 5. And so we have to also consider this fact, that whatever it is could be a huge negative number because the absolute value of a huge negative number would make it bigger than 5. And so for this one, it's not a compound. It's actually two separate. Okay, so because it's greater than, this is going to mean or. So either 3x minus 2 is bigger than 5, or 3x minus 2 is less than or equal to negative 5. Okay? And that's a big deal because it's not a big long string, and thinking about the graph helps me do that. So it's either a really big negative number, so 3x minus 2 is less than negative 5, so way over, or 3x minus 2 is bigger than 5, which is way over to the right there. Okay. We don't need this anymore. That was just helping us visualize. Okay, not because I'm crossing out because I don't want you to confuse it with our solution. And so these we just solve like we would normal. Inequalities, 3x greater than or equal to 7, so x is greater than or equal to 7 over 3. Or add 2, 3x is less than or equal to negative 3, divide by 3 on both sides, x is less than or equal to negative 1. All right, so what does my solution look like now? So x is bigger than 7/3, and x is less than negative 1. And so for this one, I'm going to have a compound. So let's look at this part first here. X is greater than or equal to 7/3. So on my number line, let's just visualize. Bigger than or equal to 7/3, or less than or equal to negative 1. Well, again, I had a compound up to start with. So it was two things. So it wasn't a compound. I had two separate things. So I had an or this. And so now my solution comes in two parts, and I'm going to write it in interval notation. It's going to be from negative infinity to negative 1. 1 is included because it's or equal to. Union 7/3 to infinity. So it could fall in either one of those intervals. That's my interval notation, and I'm putting the union to signify that it's all of those things, okay? All right, let's look at some quadratic inequalities. For these, again, any way you can solve them. But what I'm going to do first is consider this. X squared minus x minus 12 is equal to 0. So I'm going to solve it like as if it's equal. So I can use quadratic formula, I can use factoring, I can use completing the square, I can do it graphically. We're going to factor this. So if I factor this, I've got negative 12, and this is 1 and 1 because a goes there, and then b goes here, negative 1. So I need two things that multiply to negative 12 and add to negative 1. So I'm going to have negative 4 and 3. So I've got x plus 3, x minus 4 equal to 0. So check out what this means. So either x is negative 3 or x is 4. Those are my zeros. So take a look here. 1, 2, 3, 4. 1, 2, 3. Those are my zeros. And if I know a little bit about parabolas, this is not a negative coefficient, and so it's going to open up like this. And so here's the biggest thing about greater than 0. This means, is it bigger than 0? Is it above 0 or the x-axis? And so I need to look for the part of the graph that is above the x-axis. So in this case, it's this part and it's this part. Those are the parts that are above the x-axis. This part is less than 0. Okay, 0 is bigger than that. These parts are bigger than 0. And so my solution is going to be negative infinity, because it would go to negative infinity all the way down to negative 3. Not included. And also a part that's greater than 0 is going to be from 4 to infinity. Look for the parts that are above the x-axis. I love visual stuff like this, because if I'm thinking what's bigger than 0, well, if it's above the x-axis, it's bigger than 0. Then I just have to write it as interval notation. Okay, so I'm all up in this problem's business here, but this is, I'm put a neat little box here. This is 2x squared plus 3x is less than or equal to 20. For this one, we're going to do the same thing. I'm going to solve it as if it's a regular quadratic, so I'm going to make it an equal sign. 2x squared plus 3x equals 20. And so then 2x squared plus 3x minus 20 is equal to 0. When I factor it, 2 times negative 20 is negative 40. I'm doing this one on purpose because I think you're going to be freaked out, but don't be. This is 3, so then I've got 2 and 2. I don't know. So I need two things that multiply to negative 40 and add to 3. That could be kind of a daunting task, but think about the factors of 40. You got 10 and 4. Well, if I've got a negative 10 and a 4, that would be negative 6. They add together. 10 and a minus 4 would be positive 6. What about 8 and 5? And I think you're going to find there that's your solution. So I've got 8, and I've got negative 5. These can reduce, so it's going to be x plus 4. That was reducing here, so this is 1 and 4. And this is 2x minus 5 equals 0. And so x is either equal to negative 4, or if I add 5, that would be 2x equals 5. So x is equal to 2/5. Sorry, 5 halves. So x is either 2.5 or negative 4. Well, just think for a second here. What does this graph look like? It's not negative, so it opens up. And so if my zeros are negative 1, 2, 3, 4 here, and 2.5 here, which parts are bigger than 0? Which parts are above the x-axis would be greater than? But this one is different than our last one, right? This one is less than, okay? This is where they are less than 0. Okay, and so it's all this stuff down here. Well, how do I write that? Well, it's between those 2 points. So in interval notation, it would be from negative 4 to 2.5. It's between the zeros. The zeros of the graph are where it crosses 0. And so if I need it greater than, or less than or equal to 0, it's going to be closed here. That's where it is below the x-axis. It's less than 0. Okay, you are fully equipped to solve these two. I'd like for you to do that. So pause this, try it by graphing, and then find where your zeros are. Find your zeros, and then go ahead and determine where it's greater than 0. And I'll be right back after the pause. Okay, so basically, here's what I'm doing. I've got x squared minus 4x plus 1. So here we go. Turning this on. Check it out. So what I've got here is I've got my graph, and my zeros are here. So 2.68 comma 0, 3.73. So my zeros are x equals, and let me pull that back up again, 2.268 and hello, 3.73. So let me just put these on the graph real quick. So here's 2.268. Here's about 3.73. It looks like this. My question is asking me, where is it bigger than 0? Okay, greater than or equal to 0. It's this part here, because remember, this extends into infinity. It's this part here, extends into infinity. And so my answer is the intervals that cover all of those. And so it's from my x values, negative infinity to 0.268. And is it included? Yes, it is included because it's or equal to. Okay, or equal to. Union from 3.73 included because it's equal to infinity. The part where students get confused is they think, well, is it the y values? These represent the x values. Those are the x values. The interval is made up of the x values. So don't use the y values, use the x values. The y values tell you, is it bigger than 0? The x values tell you, what is the interval defined as? Okay, this one. Actually, this one's really interesting to me. So here it is, here's the graph. Okay, so here's my graph of this one. And it's asking me to find where it's less than 0. And so if I check out this graph, I have a parabola with its vertex at negative 1, 1. So here and here. So the question is, where is it less than 0? Where is it below the x-axis? Yeah, I just jumped. Where is it below the x-axis? And the answer is no solution. It can't have a solution because it's never below the x-axis. If it's never below the x-axis, it can't be greater than 0. However, if it was asking you where it's greater than 0, you could say from negative infinity to positive infinity because it's always up there. Okay, here we go. One more graph. Here's a cube. It doesn't matter, folks. It does not matter. Check this out. Here's the graph of that cube. I'm still looking for zeros, so 1's here. So if I have, find the zeros, negative 1.681 and negative 1 and 0.68618. So at negative 1.681 and at negative 1, 0 and at 0.618, it goes like this. Check it out. It goes up and then down. Up. A little bendy right there, but you get the idea. It is asking me to find where it is greater than or equal to 0. People look. People look. Where is it greater than or equal to 0? Look. Where is it greater than 0? Well, between these two zeros here, it is greater than 0. So from negative 1.681 to negative 1. Included because it is or equal to. It is greater than 0. Also, from 0.618 to infinity. It is greater than 0, and I can't box infinity. And so I'm just going to put a parentheses there. This should be 618. You guys are probably out there screaming, Mr. Sayers, please get it right. It's 618. Okay? Where is it above 0? In this little interval here, and in this little interval here, right? From here to here. It's not little. All right, vertical position of a launched object. This is physics, folks. Vertical position S is equal to negative 16 t squared plus v sub 0 t plus s sub 0. These sub zeros. This is initial velocity. This is initial position. Okay? Initial velocity and initial position, meaning where does it start? So, as soon as it starts, whoosh, gravity's pulling on it. Okay? So pull up, pull down. These two account for where it where it started, vertical height-wise. This accounts for how fast it started out. This is the pull of gravity here. So a projectile is launched straight up from the ground level, initial velocity of 288 feet per second. When will the projectile's height above ground be? 1152, so 1,152. My vertical position of this thing is negative 16t, which is time, squared, plus 288t, because that's my initial velocity, and ground level means plus 0. I want to know when my position will be 1152. So 1152 equals negative 16t squared plus 288t. I don't need the 0. I can solve this like a regular quadratic. So here's what I'm going to do. Negative 16, I'm not going to do it like that, folks. I'm not doing it. I'm getting rid of that negative on my lead coefficient. I've got 16t squared. I moved it over here. Minus 288t plus 1152 is equal to 0. Like any other quadratic. And I'm going out on a limb here. I'm going to divide by 16 to see if I can get my lead coefficient to be 1. And guess what happens? It does. T squared minus 18t plus 72. How did I know to do that? I just tried it. I'd love to have a coefficient of 1, lead coefficient of 1. How easy does that make it to factor? All right, you're thinking, well, this doesn't look easy to factor at all, Mr. Sayers. What are you talking about? So, 72 up here. Negative 18. I got 1. I got 1. So what goes in? Well, I need two things that multiply to 72 and add to negative 18. Well, if you don't know what multiplies to 72, start dividing. You know it divides by 2. 2 and 36 don't add up to negative 18. However, I know I've got to have two negatives because it's got to multiply to a positive. And so what comes out is negative 6 and negative 12. T minus 6, t minus 12. So t equals 6 and 12. Watch. This is the graph, folks. At time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. At time 6 and at time 12. Those are my zeros. Well, folks, think about this for a second. What I just plotted was a rocket, okay? And I set it equal to 0 because I want to know where it's above 0. Well, 0 was assuming that my 1152. So this is where it's above. So at 6 and 12, it is, it's at 1152 feet because that's what I set it equal to initially. Look. Okay? So when I solve for my zeros, I'm saying this is my threshold. Okay? This right here is my threshold. This is 1152 feet. So if I'm asking you when it's there, it's when it crosses that 0, which was 1152 now because that's what I set my equation equal to. So at time 6, and it goes up and it's come back down in time 12. So it's at 1152, up, 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 down, 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 back at 1152. Okay? When will the projectile's height be at least 1152? Well, all of this is greater than 1152. So between 6 and 12, and because it's at least, meaning 1152 works, it's included. So between 6 and 12, it's above that because it's flying, 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 coming down, 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 down. Okay? That's solving inequalities, folks. If you have any questions, please contact me. But thanks for watching, and we'll see you next time.